Hello, astronomy class. So we're once again doing some problems, a little bit of math mixed in with our science for astronomy class. This is for our radiation chapter, or light. And I'm going to break this up into 3 different short videos. It's the first 3 problems, the next 3 problems, and the next 3 problems after that. And they're sort of grouped together in how you do them, so hopefully that'll make sense. So for the first 3, we are using that equation, our wave speed equation. This is how fast the wave is going. Light, the speed of light, is a constant. If you don't know it, you can look it up. It's probably even on your sheet. No, I don't see it, but we'll mention it. The frequency of the waves, how many waves per second, and the wavelength of the waves. So for both numbers 1 and 2, they mention where is this here? Find the frequency and then find the wavelength. So you probably know one of the things, which for light, the speed of light being always the same, is 3 times 10 to the 8th meters per second. Now a quick disclaimer, it's not always the same if it goes through different substances like glass. But in a vacuum, it's always the same. And for number 1, they give us the wavelength of the light. It's blue light. And so we know 2 things. We don't know the frequency. How do you get this? This is like our x. All you got to do is divide by this on here, this side, and do the same thing on the other side. So you'll probably need a calculator for this. You've got to use scientific notation. You might even want to put both of these in parentheses so that your calculator doesn't mix up the order of operations. But we do ultimately want to simply divide that number by that number, and we will get a big number. Specifically, it's going to be about 6.3 times 10 to the 14th. That's in hertz. I might have neglected, no, I did put units up here. That's always a good thing. So that's number 1. Now for number 2, I'm not going to do that whole thing again for you. I'm just going to mention that it's the same equation, and it's the same sort of speed of light, except over here you know this thing and you don't know that one. So that's really very similar. For number 3, that's a little bit different. It's not even a light wave. It's a slinky wave. On the floor, it makes 6 waves in 3 seconds. Per 3 seconds. Whenever you say in 3 seconds or per, that means divide by. So if we've got 6 waves in 3 seconds, how many waves do we get every single second? It's 2 every single second. That's 2 hertz. So that's letter A. And for letter B, we're going back to that same wave speed equation that wants us to find the speed of the slinky waves. We are using the frequency we just got, and I think it says in the problem you measure the wavelength. So maybe you just look at it and it says 0.75 meters. So 2 times 0.75 is going to be 1.5 meters per second. So first 3 problems, not too bad. Like usual, these will not be collected. I'm not going to check your work, but you really should make sure that you do it. Because like usual, some of these will appear on our next test, which will be fairly soon. This is a short chapter. Okay? So click on the other video links if you need help with the other ones.